The graph of a function, Chapter 2, Section 2. Graph of a function, the collection of points x, y that satisfies the equation y equals f of x. So it's just a visual representation of a set of points. Here's an example. F of x is equal to 2x cubed minus 5x. Ignore that little vertical line. That's because that's where the cursor was when I did the screen capture. And we see that we have a graph of this function in red. Vertical line test, a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. Remember we said that functions were special relations where every input had only one output. Well, if we think of that visually, then we realize that that means that any vertical line, because a vertical line exists at a certain x value or input value, will intersect the graph at only one point because it can't possibly have two or more y values. So if we look back again at this function that I had graphed and we draw a vertical line, we see that I can move this vertical line anywhere on this function and it will only cross that function at one point. So it is a function, it passes the vertical line test. Well, we can obtain a bunch of information from and about graphs of the function. So here I have a slightly blurry version of a graph. And I want to find out what is f of 0, f of -4, and f of -5 on this function. What is the domain of f? What is the range of f? I want to list the intercepts. I want to find out how many times does y equal 1 intersect the graph? And for what values of x does f of x equal -2? For what values of x is f of x greater than 0? Now we look at this and we can see that this passes the vertical line test. There is nowhere on this function that you can draw a vertical line and have it cross through the function more than once. So let's find these different things. So f of 0, when we look for x equal to 0, we find that occurs at the origin. So f of 0 is equal to 0. When x is equal to -4, y is equal to 4. So f of -4 is equal to 4. And when f is equal to 5, or x is equal to 5, then f of x is equal to 3. The domain is the set of all x values that are part of this function. And we see that this function starts at x equal to -4 and ends at y equal to 6. Therefore, the domain is -4 inclusive to +6 inclusive. Remember when you're dealing with interval notation that the square brackets mean the value is included and that parentheses mean the value is excluded from the interval. The range is from -2 inclusive to +4 inclusive. Notice the lowest point on this graph at the bottom there is when y is equal to -2, and the highest point is when y is equal to 4 in the upper left-hand corner. The y-intercept, it only crosses the y-axis at one point, and that is at the origin, so the y-intercept is at the point 0, 0. The x-intercepts, we see that it crosses the x-axis at 3 different points, at the origin 0, 0, at the point 4, 0, and at 6, 0. If we look for the line y equal to 1, that's a horizontal line when y is equal to 1. And we see that that will intersect the graph at 3 different points. 1, 2, 3. F of x is equal to -2 when x is equal to 2. So we can see that when x is equal to 2, y is equal to -2. f of x is greater than 0 over the interval from -4 inclusive to 0 exclusive. If we were to include 0, then f of x would be equal to 0, and that's not part of that inequality. We're looking for when f of x is greater than 0. It's also greater than 0 from 4 to 6, excluding both the points 4 and 6, because that would make it equal to 0. We can also obtain information from and about the equation of a function. So here we have f of x is equal to x minus 2 over x plus 1. If we want to know what the domain of f is the point 2, 1 on the graph of f. If x is equal to 1, what's f of x? If f of x is equal to 1, what's x? And what are the x-intercepts of the graph? Well, we can start out by looking for the domain, and we know that the denominator cannot be allowed to be equal to 0, so we find out when that will happen. X plus 1 equal to 0, subtract 1 from both sides, x equal to -1, so we know we cannot allow it to be equal to -1. Therefore, the domain is from -infinity to -1 exclusive, united with -1 to infinity. Is the point 2, 1 on the graph? The easiest way to do that is to plug in 2 for x and see what y turns out to be. So when we take f of 2, we get 2 minus 2 over 2 plus 1, or 0 over 3, which gives us 0. That is not 1, so no, the point 2, 1 is not on the graph. If x is equal to 1, what's f of x? That's just plugging in 1 for x. So we have 1 minus 2 over 1 plus 1 gives us -1 over 2, or -1/2. If we want to know f of x equal to 1, what is x? Then we set f of x equal to 1. We have 1 equal to x minus 2 over x plus 1. Multiply both sides by x plus 1, and we get x plus 1 is equal to x minus 2. Subtract x from both sides, subtract 1 from both sides, and we get 0 is equal to -3. Well, what that tells us is, because obviously 0 is not equal to -3, is that f of x cannot be equal to 1. 1 is not in the range of f of x, and if you were to graph the function f of x is equal to x minus 2 over x plus 1, you would find that y equal to 1 is actually a horizontal asymptote. And what are the x-intercepts of the graph? That's when we set y equal to 0. So 0 is equal to x minus 2 over x plus 1. Multiply both sides by x plus 1. We get 0 is equal to x minus 2. Add 2 to both sides, and we get x is equal to 2. So we have an x-intercept at 2, 0.